Alright, morning everybody. We're going to continue on with our coasts, alright? We were looking at the erosional landforms, our headlands and bays last week, and we're going to continue on with the next and final set of erosional landforms. We got all our information here, so head up. You're going to make some notes and one or two sketches today as well. And we'll have to do some reading as well, okay? First thing I want to bring your attention to is I attached this document. It's called Coast Vocabulary List, okay? Now I've made a note here. It is an extremely comprehensive list of all the vocab you will come across, all right? You do not need to learn off every single thing on here. We will cover pretty much all of these words during the lessons. We've done nearly half of them already, okay? But if you can print it out, I would advise you to just put in your binder in the coast section, because it has all of the keywords that you will ever need to look at or come across. And if there's something in an assignment you don't understand, chances are the word will be on that list, okay? So that has been sent to you in the weekly outline or forecast I sent last night. Right, first of all, just two keywords I want to make a note of. Okay, we will look at these a little bit later, but not in great detail, so I just want you to know what they are. Okay, I've also added in how they mainly form, which again we look at in Bunnet and Bahamian landscapes. Okay, so honeycomb weathering, this is the term given to jagged or very sharp rock surface left behind on some Bahamian coastlines. Again, any of you who've been to some of the Family Islands may have noticed, if you ever try and walk on some of this rock surface, it's extremely sharp. Okay, we'll look at some pictures in Bahamian landscapes today. Blowholes then as well, we will also look at how they form. It's pretty simple. We have hydraulic action and abrasion are mainly the causes of this, and they're created through the collapse of a portion or a piece of the roof of a sea cave. Alright, now we're going to start off with our sea caves in just a few minutes. So water can actually shoot up through these blowholes, alright, and can be quite spectacular at times, okay? So what we're going to do is, once you finish these, Bunnet page 141, and we'll do a bit of reading. Now before we get in there, just, you've seen these pictures before, okay? This is what a very kind of a perfect sea cave would look like, alright? You can see the oceans here. The ocean is currently at low tide. When the tides come in, the water can enter the cave, and then abrasion, attrition, hydraulic action, those processes of erosion would slowly clear out the cave, okay, or break down the rock. We're also going to look at our sea arches today. Now again, where the glass bridge is in Eleuthera used to be an arch, but it's collapsed during a hurricane, I believe. Alright, but this was what our sea arch would look like. You can see there's no support below. Another example of a sea arch and then a sea stack, which we'll be looking at. Alright, so this is kind of like an ongoing story. This is our headland, which has been left sticking out into the sea, like we covered in the last lesson. Either side of this, where there's softer rock, there would have been the formation of a bay. You can see further along the coast here, more headlands sticking out, alright? Once they are sticking out in the sea like this, they become exposed to erosion on all sides. So the ocean attacks from the other side. You can see a cave starting to form. Alright. Once the cave goes the whole way through the headland, you get an archway. Once the roof of the arch collapses, you have a stack. Once this falls into the sea, you are left with a little stump. Alright, so we'll look at that in more detail. Again, this would have been connected to this. Alright, as a headland coming out. The archway has collapsed, and now this is our stack. And again, I wanted to point out this example because it's a very good example. Between low and high tide excuse me, is where the erosion takes place. Okay, so that's why it's getting narrower and narrower here. You can see it's being eroded away at the sides, so eventually this will collapse as well, and you'll be left with a little stump. Alright, so that being said, let's jump into Bunnet and have your highlighter and pen ready. Okay, so Bunnet page 141 is where we are now. Alright, so you'll see caves, arches and stacks. Okay, you can put the word sea in front of each of those, a sea cave, a sea arch, a sea stack. All right, these form differently. The reason I put sea cave in front of this is they form differently to the caves we saw underground in limestone. Limestone caves are formed through solution, okay, whereas a sea cave is formed by the coast. They're only found near the sea. All right. I've also added the pages for New Wider World and Bahamian Landscapes, so we'll look at these pages a little bit later on. And New Wider World is just another good resource. It's got some simpler diagrams, perhaps, if you want to use those. All right. So waves attack on the sides of a headland, all right, sometimes leads to the formation of caves, especially where there are vertical faults or joints. So I'm going to show you a picture on the next page, all right, of where the headlands are now exposed and are being attacked from all sides. Sometimes a cave in a headland or a similar feature is eroded right through to form a natural arch. And again, natural is an important word. All of this stuff happens naturally. We don't have any role in it. Okay, in time, the roof of the arch collapses and a stack is formed. Very simple. All right. So what we're going to do is, I'm just going to pause, go on to the next page. Okay, so top page 142, as you can see now, this is a very, very good example of headlands and bays. Okay, so you got headland, headland, headland. All of these pieces left sticking out into the sea are headlands. You can see the bays forming here. Okay, there's some deposition. When this is left out here now the sea can attack it from all sides. Okay, remember, the pieces of rock left sticking out into the sea were the resistant pieces. All right, they're the harder rock, but it can still be eroded, especially when it's exposed like this. All right, again, what you can see as well is you can see a kind of a shadow along here and along the very bottom. That is the area between high and low tide. Okay, so you can actually see here the cave starting to form. You can also see two of them over here. All right, so they'll happen at the bottom of the cliff. You're not going to get a cave forming at the top, are you? So over time, this cave here will get bigger and bigger and bigger and bigger. And in some cases, if there's a cave on this side and a cave on the other side, they'll reach through and connect. Okay, so that's a very, very good example there. Moving down this page, again, is another little piece I want to look at. Okay, so again, we have our headland, which kind of comes out like that. All right, now that it's exposed, it's being weathered on the top. All of this is getting looser and looser, wind and rain and so on, and plants, vegetation. I've drawn my arrows in again. Okay, erosion from all sides. Okay, the headland is being attacked from all sides. Then what else I've done? I've added this dotted line and this dotted line here. So the caves have gone the whole way through this headland and they formed an archway. Okay, and then eventual section to collapse. So all of this here will eventually collapse. Okay, and when it does, what would we have left here? Okay, we will have a sea stack left. Alright, and it'll be no longer connected to the mainland. So that's how it happens. Again, when you're describing this process, how are the caves formed? Hydraulic action, abrasion, attrition. The caves meet. There's one other force that then pulls this down. What's the force pulling us all down to the ground? Gravity. Okay, can also obviously work on that rock and make it collapse. The base of this then will also be eroded by hydraulic action, abrasion, attrition. Alright, and eventually fall into the sea as well. So those methods of erosion we looked at before, these are still all erosional landscapes. There's no deposition occurring here, okay, or transportation. It's just erosion, erosion, erosion. Alright.